On this video, we will review the connection of the SmaRTK to any Android device. In this case, we have set it up as a course. So we put a SIM card here on the receiver. And if you see, we didn't put UHF antenna because we are not using the radio modem. We are starting now the system. And the OS is now starting, you can see. So we are now in a urban environment under trees, basically located in a park. So you can see it's a cactus here and some signs. There are many trees, and we are besides an avenue with some traffic and a roundabout that we will collect later on mapping software. So the system is set from before as a robot network. Now it's in single mode, and you can see there are some satellites. We have 8 GPS, 5 GLONASS, 2 Compass, and of course Galileo. And here you see the modem that is connecting to the network. The time of this connection really depends on the phone company. So like any phone. So now we have connection right now. We see the bars, and now the location of the satellites is being sent to the core station that we are using, the public Catalonia network that is free. And now we have RX of the data coming from the core station, and now see that the solution is float and will change very soon into fixed to have accuracy for solving. Now we have fixed, and we can now confidently solve with high accuracy. So what we are doing now is to connect to an Android device that is basically a phone. And first thing is going to the Bluetooth. So we will look for the device. It has never been paired, so we look for it. We find it here. We select the serial and pair it. We wait for the pairing. We'll maybe ask for a password, normally not. So we click in pair, and we wait for the connection to be established, and we can then move to any software. In this case, we will get this generic Bluetooth GPS software that is not specific for RTK. We will select the Bluetooth here and connect, and we will see the UTM lat long positions appearing. So we can check the sky view, and we can see that the accuracy is 2.1. So we have to be careful because not any software that is capable to read NMEA is able to reproduce the latest version. So we can see here the NMEA data log, so is correct. So we will disconnect this software and go to a mapping software that is capable for RTK translation. So the SW Maps software, we will start a project here, and then you can see that the point is jumping here in the left, and this is because this is the GPS of the phone. So now we will connect to the SmaRTK using the Bluetooth GPS connection. We select generic NMEA that is common to any software, and so we can put here the instrument height to 2 meters, just to simulate the height of the rubber rod, and connect. So we can see the latitude and longitude and elevation, and it's fixed RTK solution. We can see how the solution is. Here we have the position and the height. We can see that it's quite stable, and HDOP because it's fixed RTK. And we can see the sky view. We are using now 10 satellites out of 21 in sky view because we are under the tree and besides a building. And now we can record a feature. We will record the roundabout by time, and then we start collecting. You see this is quite stable, so we begin moving. The icon in green means it's fixed. So we go to the starting point of the roundabout, and we start moving around. We will see that the line is quite parallel to the photo, the orthophoto, but it's not quite there because the error of the Google Maps translation. But that doesn't mean that the accuracy is precise. You can easily see what are the advantages of this capacity to use any software on the SmaRTK that gives you freedom to choose many softwares beyond the restrictions of the RTK specific software. So you can use GIS, echo sounding software, and it will be as easy as this to connect. Many of our customers actually develop their own softwares for GIS or robotic applications. So for the world of photogrammetry, robotics, UAVs, this is very, very comfortable. So you can see now we are following the track, as we say, a bit in parallel, depending on the orthophoto that is provided. And we are passing through several signposts, trees, many passing cars, and the solution is always fixed. That is because the antenna capacity of the SmaRTK is quite high, so the gain is allowing that any problem of the scenario that we can confront is easily solved by multipath filtering. So we are moving along, and we soon will be closing the loop of the stakeout, let's say, the collection on this basic software, and we will close the feature. So you can see with a very basic software, we can actually do a quite accurate surveying job. We will now reaching the point that we will close the feature. And we can review now how the collection was made, and now we will disconnect the Bluetooth GPS, and we will now see how to connect any software that is not prepared to connect by Bluetooth to an external GPS. We will go to a software that is called GPS Provider that connects to Bluetooth to the GPS and replicates internally on the system as it was an internal GPS. So then now we can go to any software. In this case, we will go to Google Earth, and we can see that we will use the external RTK in a software that is not prepared for external RTK use. So now we go to My Location, and we will see in 3D where the actual GPS is located. We are on the that tree exactly. And we can explore the capabilities of using a 3D software or any other type of NMEA compatible solution with the SmaRTK. And as you can see, the most different part of any other receiver is that we did not have to use any software or device to set up the receiver to start working. So we can connect to basically anything. Now we can then switch off. We go to the menu and switch power off. And that will be all.